4 years ago, I was working on a book about COVID. It was actually obviously in the midst of the crisis, and I was doing my research and in the process of getting that ready, which never came to fruition. I came across a small book about how to prevent and treat COVID, and this was before there were any vaccines. The book was titled "Stay Safe," and the author was Dr. Stephen Quay, who it fascinated me, presented a lot of unique approaches to combating COVID that were actually very simple. And we'll discuss that hopefully later in the podcast. I also subsequently learned that he had a company called Atosa Therapeutics that does research into innovative approaches to breast cancer. I was like, whoa, this guy's into COVID and breast cancer. That's quite a range of interests. And I wasn't really sure the connection. Dr. Quay has really impressive training and quite the body of work. He's received his MD and PhD from the University of Michigan. He was on the faculty at Stanford University Medical School. He's got over 6,000 citations for his articles. He's invented 7 FDA-approved pharmaceuticals. He's got 87 US patents. So he's kind of this combination of an academic dynamo with a Shark Tank business acumen. But I think what you will see, what's intrigued me and made me want to interview Dr. Quay was his unconventional thinking in combating breast cancer and other illnesses. He's a little bit like Elon Musk, who, like with his Neuralink program, wants to reverse paralysis. And he says, like, why does science have to be so conventional? Why does it take so long? So I'm really pleased to welcome from, I believe, Taiwan, Dr. Stephen Quay to the podcast.
Yeah, it's great to be here, Dean. It is 9:01 in the evening in Taiwan. So
Oh,
it was a
wow.
good day. I hope you have a good day on your side of the earth.
All right, appreciate it. I appreciate you doing this, yeah, with our wide time difference. Okay, let's start a little bit about background and a little bit your credentials and your mission. Now, again, from reading your book, just the first one, Stay Safe, and we'll get to the other one as
Mhm.
well, the origin of a virus. But you struck me as an unconventional thinker, as a doctor, a researcher, obviously with your academic credibility, so it wasn't, things that were, out there in the universe. And you're also an entrepreneur for sure. Um, and then I saw on your website when I went there, it says you have this mission to improve breast cancer diagnosis for all women. So I had a couple of questions I wanted to ask. Essentially, what motivated you to focus on breast cancer? Was there a personal connection somewhere in your family? And the other part of it is, as you can imagine, you're not an oncologist, I believe, you're not a radiologist, you're not a gynecologist. What expertise did you bring, or did you just think being an outsider was going to bring light to this disease that's affected so many women?
Dean, there's a lot of questions,
I
yeah,
know,
I
I
need
know.
to
So I'm gonna let
unpack
you
all of
take it
that.
away for that. Yes, yeah,
Yeah,
work it. I just didn't know which way you want to approach it. So,
it's entirely up to you, of course. I mean, the my life has been one of trying to look for kind of the most bang for the buck. So you go to med school and then you can be a doctor. You probably have 5 to 10,000 patients, if you're really, really busy. And then I started teaching at Stanford. So now I could have, 85 Stanford medical students who then will amplify it.
that's
And,
right.
and then I got the idea of, well, if I could come up with a drug that could be used, even when I'm sleeping. And so the first drug I invented was a gadolinium that's used in MRI imaging. It's been used about 60 million people. So that event in my 30s, going from, pure academics, Nobel Prize. I won the Nobel Prize. Everybody wants the Nobel Prize. But anyway, teaching at Stanford and then realizing that I really was good at what I call overlapping Venn diagrams. So things that shouldn't be brought together, two different fields juxtaposed, I could see the overlap and allowed me to, enter new fields. And my patent number now is 91, but they actually cover 22 different fields in medicine. So, I'm a nerd, I guess, deep down inside. So I do a massive amount of reading in all sorts of topics. Um, and when I see something that interests me, like COVID in January of 2020, and I suddenly get a flashback that this thing called the furin cleavage site is exactly the same sequence I had in the toxic bee venom melittin, the thing that hurts when you get stung by a bee. I remember telling my board on February 1st, I know exactly what this virus is going to do when it encounters a membrane because I spent 5 years at Stanford writing these really esoteric people that 5 people in the world, including my mother, read. But nonetheless, they are a foundation in biophysics that really helped me, some 20 years later, 30 years later.
You know, you say something really interesting that I believe too so strongly. Like some of the times the best discoveries and breakthroughs is when any even kind of specialist breaks out of their area and overlaps in another area because you when you work in a silo, when you're just looking at one thing and you're not intersecting, seeing any type of
Hmm.
common thread, I think that is true. That's where the big breakthroughs come through. You just answered my second question, why you started a pharmaceutical company, so that made that one easy and that's staying in academia or just treating patients. Um, Before we get into the breast cancer, I just have one quick
Sure.
question too, because you emailed me. I didn't have a chance to check it out. You said that you got 2.2 million followers on a tweet you done the last week. What was that about? Had to be something pretty explosive.
Yeah, well, I don't understand. I don't understand X or whatever you want to call
Okay.
Twitter X. But
Yeah.
so I can't really predict why things happen the way they do. But it was a very specific one about a paper from UCSF that showed that the foundational mechanism for the problems in COVID, long COVID, is this strange interaction with a spike protein and a protein called fibrin, which is the thing that we lay down in our vessels to form clots. Think of
Right.
fibrin as that Dutch boy with his finger in the dike. And so every time a vessel gets a little leak, the body makes fibrin and it
Mm,
closes it up. Well, it turns out that spike protein has unique sequences that bind to that. Unfortunately, what that also means is that when it does that, it can form clots,
right.
microclots in the brain,
Yeah.
fog, just COVID fog, in the heart, other aspects, and it also can be a trigger. The inflammation process can be a trigger for cancer. So it all
Mm,
sort of laid down as one common foundation of all the things. When you can collect so many different things from the long COVID to cancer from a single virus or vaccine, it's pretty uniting. Um, and some
okay.
people also forwarded it that
So they
have
were
pretty
really
high
interested. Yeah,
visibility.
we're going to
So
get into the COVID second. I want to
sure.
really dive into first the breast cancer
Yep.
issue. Okay. So I got a chance last night to look at your TED Talk, which was very interesting. And,
Mhm.
you obviously discuss your thoughts and some of your approaches to breast cancer. And I believe in your words, you were explaining how the conventional treatment for breast cancer is cut, burn, and poison.
Yeah.
And I don't think a lot of people would disagree with that. And it sounds like you're not too much of a fan of modern breast cancer treatment, although we do have to admit thousands of women's lives have been saved using these approaches. How do you see in your ideal world the treatment of breast cancer? Would it be, before we get to your prevention approach, would it be a vaccine, immunotherapy? How do you, when you once, unfortunately, God forbid, a woman has breast cancer, with your kind of thinking, what do you think will be the magic bullet if there can be
Okay.
one?
Okay. So, Dean, I need to correct you because
Yeah, sure.
I am probably as sort of a mainstream oncology approach to breast cancer of any doctor
Oh,
out there.
okay.
So in talking about the aspiration of preventing breast cancer, I do kind of bring out the emotional side of cut, burn, and poison. But there is absolutely no position I would take that doesn't say that, depending on the stage and the kind of cancer and what you see under the microscope, because I'm a licensed pathologist,
Mhm.
those especially surgery and perhaps radiation and even chemo afterwards are absolutely essential. I
Mhm.
am not an alternative medicine doctor by any stretch of the imagination, so
Okay.
let me be very clear on that.
Okay,
Um,
sure.
so then backing up, the Otosa was started based on a fundamental question: is why isn't there a pap smear for breast cancer? Because if you look at the properties of the pap smear and what it has done for cervical cancer, if you brought that over to breast cancer, instead of having one new diagnosis a minute while we're chatting here, which is one a minute, we could eliminate perhaps half or 60% of those in one fell swoop. And if we want to go into the details of that, I'm happy to, if
Yeah,
that's the
yeah,
direction
that
you
was
want us
actually
to
my
go.
next question. So, well, okay, so let me ask you, because again, for the listeners, because they're probably not aware of this, I wasn't aware of this till I watched your TED talk. I mean, you do make that very interesting analogy that Dr. Papanikola, who was very famous for inventing the Pap smear, which does save millions and millions of lives, catching early detection. And then you talked about going into the stacks. I don't know if people appreciate that back in the day before the internet. You had to go to a library. I remember doing this at Brown University and stuff like that too, and going into the basement there and sorting through these dusty journals to, to find, something that interests me. And you mentioned that you saw that Dr. Papanicolaou had also published, but had definitely fallen by the wayside on breast nipple aspirates to detect breast cancer as a screening tool. And I think you mentioned in the talk that it was just very hard to get enough
Mhm.
aspirate. But I just have a question too, also, like, how would that aspirate help you if someone has a deep cancer in the breast? I mean, will it would get those cells? And maybe you could obviously explain a lot better than I can about, uh, what how this would work, and also a little bit how you were developing a better way of collecting this, but then you got derailed. I think you mentioned a little bit by the FDA. So maybe you talk about
Yeah,
that.
yeah. So a lot of conversations
Yeah,
there.
again.
Um, the breast is an amazing organ. It's the only one that's not formed at birth. It forms, during puberty. As Susan Love, my dear friend of mine who was pioneering this work, passed away here 3 or 4 years ago of cancer herself. But nonetheless, she says, it's a miracle because it turns blood into milk, which is, it's a little bit of a stretch of the imagination.
Yeah.
But so the breast is only 3% of the cells that can form cancer. So the breast is made up of the fatty supplies and supporting tissue that are going to be the supplies of making milk in the future, the lobules that actually do that final processing, and then the ducts that conduct it to the nipple. And the whole system is absolutely connected, like a good plumbing system, so that, or the Mississippi River, which has tributaries, over half the U.S. But every drop of water ends up, in the Gulf of Mexico. So by sampling the exfoliated cells. So the cells are growing on the lining of the breast. So when you get breast cancer, only 3% of your breast has cancer. The other 97% is completely benign. Then the other crazy thing is at puberty, it's like the march to the west out of St. Louis when they rang the bell and people went out and got their 640 acres. So as puberty starts, there is a race for cells trying to grow back into the breast, make the ducts, make the lobules to make a mature breast. And there are really only 12 units at the nipple itself that end up making lobules. When a woman gets breast cancer, 95% of the time, it's only one of those 12 where she has cancer. The other 11 are perfectly normal. So there's some really interesting biology around this. But so what I intended to do was to collect this nipple aspirate fluid as a sample of the environment of the entire duct system.
Okay.
It turns out that that's a pretty effective way to do that if you get fluid and cells from a woman.
Okay. And why did it? I know you were working on that too. What was it? Just politics, or was there
No,
some
no,
type of?
no,
Then why,
no.
why did it get
Well,
derailed?
it's not a matter of being derailed. So the cervical scraping when you do the Pap smear gives you 30,000 cells, under the microscope because I haven't had a Pap smear. I've performed Pap smears. I've talked to women who have it. It's unpleasant because you're
Right,
you're
right. You're going right
literally
to the tissue. Yeah, you're
you're,
literally
you're
scraping the
scraping the
tissue.
tissue to get it on the slide.
Yeah.
We would get typically a couple hundred cells in a good specimen. So, 30,000 versus a couple hundred. So we had a sampling problem. And what actually came not out of the blue, but kind of walked along and we grabbed it was a parallel biology, which was beginning to show that the background density in a mammogram, that is, whether it's very low density where the mammogram is largely black or it's high. So what was happening is we did not have enough cells in our nipple aspirate fluid to really make it a viable screening test. We had a couple hundred cells. A Pap smear gives you 30,000 cells. But in parallel, this process called mammograms and mammographic breast density, which is the background whiteness. So it's very dark to very white, and very white is a 5 to 8 fold increased risk of cancer over the next 10 years. That process became a biomarker that I could latch onto. If you're thinking about preventing breast cancer, while it happens in 1 in 12 women, it also doesn't happen in 11 out of 12. So you can't really come up with a drug and say, I'll give it to all 12 women, and we won't give it. You have to be focused. So what focuses us? The focus point is the density on the mammogram. So what we start with 39 million mammograms in the US for women 40 to 65 or 70. And then about 8 to 10 million of those are high density. So that's the only population of women that'll get breast cancer, which is kind of interesting. So that's the population we want to look at treating. And it turns out that from prior work, if a drug can change that background density, which you can measure in as little as 6 weeks and 6 months
Hmm.
to a year, you actually do prevent future breast cancer in 5 years. So it's a really
Hmm.
tight biology of biology makes it dense. That we don't understand. That's a nice Nobel Prize for somebody. But anyway, the mammogram picks it up. You treat it, the density goes down, and the incidence of cancer goes down.
When you say
Is a
treated with what? What would you mean?
well,
Would be
so we
chemotherapy or
are
something?
we are finishing we are finishing a trial with a drug that mimics estrogen but blocks its activity. So far our side effect profile, I'm knocking on wood because you've only done about 1,000 women, and we want to use this in millions at some point in time. But our side effect profile is very good for a preventive product where the threshold,
Mhm.
if I'm treating cancer with a woman who has a 5-year survival rate of 50%, it's different. Side effects are different than in a prevention mode. So it has
Okay.
a very, very benign side effects. But we're finishing a trial that's going to read out in the next couple months where we took women at high density at the Karolinska Institute in Sweden, which is where the Nobel Prize is given out, very major cancer center there. We took women with high density and we gave them a sugar pill or we gave them 2 doses of this drug that blocks estrogen. And as I said, we don't know what happened. We took mammograms for 6 months, but we'll see the data in the next couple months. And if it's positive, which I feel I've done this science now for 10 years almost, so I'm feeling pretty good about this drug that I invented. Um, we will then have the foundation for preventing breast cancer in a further study.
Wow, that's pretty awesome. Can I ask one thing with the aspirin too? There's no possibility of what they go call, I guess, like genetic amplification, like even if you had a small amount of those cells to sort of, you know, get, almost like what they do with infectious disease these days. You can get a small microbe and somehow, like, I guess, amplify from the DNA and find out what the organism is. But that's not possible at this point, or is that another one of your on the
No, no,
radar?
Dean, there's probably a reason this is called the smartest doctor podcast or whatever, the smartest doctor
Well,
in the
my
room
guess.
podcast.
That's why. Yeah, that's why I brought you
No, not the
on.
guess. It's you. It's you, man. It's you, man. So you're absolutely right. So what Dean is talking about is there's lots of different classes of biological molecules, but one of the most interesting ones are what are called nucleic acids, DNA and RNA, because they have this property of matching a complement to themselves. And there's these really simple techniques, PCR, we all know what those initials mean now, of taking like one molecule and making millions and millions of molecules. So we did a study. We're doing a study at the University of Utrecht in the Netherlands on nipple aspirate fluid and amplification of what are called microRNAs, which are these small RNAs. They're on the order of 20 to 30 to 40 nucleotides that control genes, and they look like they're aberrant in women who will potentially get cancer in the future.
Hmm.
So the science part of me finds this really, really cool. And then the doctor says, let's get something to the market to cut the 250,000 women a year getting breast cancer in half. So I'm playing both sides of that with my time and with my, with what Datos is doing.
You also wrote, I think it's on your website also too, that you wrote an article about your mammogram, the questions to ask before, during, and after. Is there a few things you could let the listeners know that might be very important, because obviously so many women are going for annual mammograms, that they should know. Maybe,
Yep.
again, being proactive is also really what the podcast is about.
Excellent question. Um, Women starting at 40, or if they have some risk factor, like a lot of family history, or maybe what is called this BRCA gene, which is a founder gene in the Ashkenazi Jewish populations in Eastern Europe. 35 for those ladies at higher risk, but 40 for the rest of the women. And your first mammogram is important, but then going to the same clinic and even especially using the same technician if you can over the years builds a record because the most valuable diagnostic information for your doctors is the serial changes. So, you know, a great radiologist can find cancer in any mammogram. There's five of those, including Dr. House on TV. So, but for most radiologists, having two mammograms, one from a year ago or 2 years ago, and the other one, they can go back and forth, and really,
That's very important.
really get to that. AI is changing that, and part of what we're doing in the Karolinska Institute is actually an AI driven. We basically gave an AI machine 100,000 women, 100,000 mammograms from women who did not get cancer, and 10,000 from women who did get cancer, and we said we're going to go have breakfast and lunch. You figure out what's the difference between these two and then we came up with an algorithm that is highly predictive of these women who are going to get cancer in the future using things that the human eye doesn't understand,
That's
which is
phenomenal.
what's annoying. I mean,
No, it's
I
phenomenal,
like the human
really.
brain to be the smartest person in the room, but
Well,
these
you know
AI
what?
AIs are going to be
You
a
know what I say
challenge.
about AI, and I think in medicine it's going to have dramatic effects, is that the wrong term was artificial intelligence. I like the idea of assisted intelligence. Like it's going to be our
Mm.
major assistant. So, as much as you and I through medical school and all our training, we store all this stuff in our brain. It's just a great like checklist to make sure you don't miss something, and then use that tool to to optimize obviously your lifetime of experience and mine. um this was really great. We're going to take a break just for a few minutes, and then we're going to come back and we're going to find out this is probably pretty interesting and exciting for any of our listeners, how Dr. Quay got involved and wanted to step up with the COVID pandemic and fiasco. So hold on there. Okay, we're back with Dr. Quay, and I'm really interested. You started to say in the beginning how you decided to get involved in COVID. It's interesting. What was so incredible about the pandemic, I mean, the one positive thing was you saw all of these, even university labs, everybody piling in their resources to combat this pandemic. I mean, I've never in my lifetime heard, when people were working on this type of paramecium, on this chemistry thing, say, you know what? We're all in. We're gonna any of our scientific background. We're gonna contribute to tame this pandemic that was literally killing thousands and thousands of people. Um, you know, One of the things, as I said, I hope we'll briefly talk about some of these things. Like in your book, Stay Safe, what I really liked, believe it or not, was besides your approach and explanation, of the transmission and, really basic things that like it's almost like anybody should know, was also some of your simplistic things. But I mean, I'm not just talking about the mask. I'm talking about like how you mentioned like putting like a saline coating on the mask. So I assume that was kind of like your biochemistry background or something. So tell us how, again, you're not an infectious disease doctor. You're just like an out of the box thinker. Why you decided to get involved and obviously write the book, and then we're going to talk about even obviously more of your interests in how COVID originated.
Yeah, yeah. Well, so I mean, look, I mean, as a pathologist, you are trained to understand diseases at the molecular, cellular, tissue, and organ level. As part of those 22 fields of medicine, I have patents for viruses. I have patents for DNA.
Mm.
I helped invent one of the nucleotides that's used in some of these vaccines and things from a chemistry point of view. So I do have that broad background, but I mean, I think one of the things that I'm sorry, you asked about specifically about the mask. No, Dean, I cannot take credit for that. So there's a patent from a fellow in Canada who showed so what the principle is showed what the effect of salt on the outside of a mask is.
Hmm.
You start with it starts with salt water and then it dries. And so what happens is when a droplet of a coronavirus, which is somebody sneezes, and you have this sort of if it's a big sneeze, it might be a 20 micron droplet, but if it's an aerosol, it's down below 5 microns. I was a colloidal chemist for 5 years as well. So
It's
in any case, when this liquid droplet hits the mask, by capillary action, it's going to spread out. So it'll maybe make a millimeter spot in there and that sort of thing, and it'll start to dry. Now, when it dries normally, the virus is preserved on the surface of these masks, we know, for hours and hours and hours and hours and hours.
wow,
Okay,
wow.
so what happens if it hits a mask that's been treated with sodium chloride? As it dries, of course, the sodium chloride gets more and more concentrated, and at about twice the tonicity or the amount of sodium chloride in your blood, when you get to twice that level, the coronavirus explodes. It
Wow.
explodes, and its RNA is completely destroyed. So the drying of saline, it gets wet, the virus is sitting there. As it dries, the virus is just blown to pieces. So this guy got a patent on this in Canada, um, for doing this, for making them, for selling them with his salt on it. I wasn't infringing his patent by telling people to do it,
No, it's
and it's
amazing.
but it's solid science. I mean, this guy's an engineer. He's a mechanical
Well, think about all the,
engineer.
which is so crazy. Think how valuable that would have been. There's so many. healthcare workers, nurses, technicians, the doctors, during especially the initial part of the pandemic, we didn't even have enough masks. People
Yes.
were wearing them through whole shifts. And basically what you're saying is a person was getting coughed or sneezed on or whatever, and going to the next patient
Hmm.
and endangering their own health, unfortunately, maybe even risking the next patient. I mean, something as simple as this,
Hmm.
could be such a game changer.
Well, it stays alive on the out. It stays not live. It's not. It's never alive. It stays
Right.
infect. It stays infective for
Well,
hours and hours on the outside.
right,
And
until it finds a host that it can jump to.
sure, exactly. Yeah. And you touch your face 92 times a day if
Yeah.
you're just normal, and then if you're so yeah.
Let me ask you a question. I wear a shield sometimes now these days when I'm very working up close to a patient, examining their mouth, whatever, too. Because, again, you could get even on a cough or sneeze in the eye membranes and stuff like that, too. So something like that, would you normally like, could you just take like a fantastic spray or something, just clean your shield after, or do you really need to dispose of the shield from one patient to the next? I mean, again, you don't not knowing whether they have any kind of virus or not.
No, you don't need to. You don't need to dispose of it, and a simple alcohol wash will cover it. I did talk. I don't know if I put it in the book or I put it elsewhere. Is that there was a very fascinating study. 20% of all transmissions during the first year was through the ocular surface. So it
I don't
was
remember you putting
again
that in, but I was, yeah,
a sneeze or a droplet that hits your, where does it go? It hits your cornea, it hits the fluid of your cornea, and where does that go? It goes through your tear ducts, goes into your nasal epithelium. So
yeah,
it drips on the surface that it loves the best. I mean, one of the things we found early on was that goblet cells, which are these big cells that make the mucus in the nose, it loved going into goblet cells and making them explode, as well as the nerve cells. So that's why we lost taste and smell. But yeah, 20% through the eye. So your mask is a shield is a great idea. You wear glasses that also helps you
yeah.
sort of naturally.
Like when I go on a plane, just for the listeners, so they know, even to this day, because I used to get sick a lot on planes. I mean, it doesn't have to be COVID; it could be anything. I tip, and I don't like wearing a mask for long periods of time. I don't know how the surgeons do it because I start to get dizzy. But I like having the shield over me because I just feel like it's a little bit of an extra layer of protection. Another thing that you have in the book, Stay Safe, which I liked, and again, it's so underappreciated. I think it's in your chapter, How Not to Die from COVID. You promoted also increasing your lung capacity with like a breather device. And I love this idea because it's so again they were focusing so much on the cardiovascular system. If you have heart disease, high blood pressure, I mean again all these things as you were mentioning earlier with the fibrin clotting and causing issues with the vasculature. But the bottom line is most people were dying from respiratory failure with COVID, and having a really good strong lung capacity is beneficial. And something like this breather device was such a simple idea that just, and as you know, too, for longevity, people say having good, pulmonary function, is something that tends to get ignored. So I really, again, I love this like concept and, you know,
Can I
I don't
can
know
I
where you came
comment
up
on
with
it,
this.
Dean?
Please. Yeah, please.
Yeah. Okay. So, I mean, again, I'm writing this book. I think it got published in May or June of 2020. The
Yeah.
vaccine, we thought at that time a vaccine was, 2 years away, 3 years away, whatever. And I was trying to figure out what could you do? What could you do? And Dean, you remember probably that in med school, they talked about pneumonia being the old man friend because it was a common way of people dying. Hey, I had pneumonia at 39 when I came back from Chicago, a meeting at Stanford. I was in the hospital. It is not friendly at all. It is horrible.
Mm,
So I started to say, well, why is pneumonia so prevalent in the elderly? And what could go on there? And part of our bodies, well, our bodies are really well designed if we can make them work the way they were intended to work. So what do I mean by that? So we have a coughing system which involves the intercostal muscles accelerating air out, and then the ability to make mucus to catch the viruses to prevent them from getting into the cells. But then, if the mucus gets too thick, so the things I did in the book was say, well, how can I get an old person to cough and not get pneumonia like a young person? Well, one is to get the mucus thinner. So, you stand in the shower, and cough, or you humidify yourself. You drink a lot of water, humidify from the inside, humidify from the outside, and then training the intercostal muscles. I mean, I've been a gym rat since I was in my 30s. I'm not muscular, but I
no,
do it every day.
look pretty good.
Not bad. But what you never train, Dean, in the gym are the intercostal muscles. And then I started looking up papers about what these little devices do. And Example, a 2-week use of this device before elective surgery reduced hospitalizations by 1 day, which the
Wow.
hospital administrator will tell you that's an $8,000 savings.
Wow.
So you go from nothing to using this for 2 weeks to then having elective surgery. You're going to not have pneumonia. You're going to have a quicker recovery. You're not going to be in the hospital as long. And there's 5 or 6 articles about that that really added up to. I really wanted to be sure everything in my book was peer reviewed. It wasn't my ideas. They started as my ideas, and then they went to the literature
Well, you
and said,
brought it
"What
all together in a
I did
very
exactly.
simple
I
book,
did."
which is so important. I just want to comment again for the listeners to really appreciate what Dr. Quay is saying. Most of my career too, I've treated a lot of asthmatics. It was part of the
Hmm.
allergy component of my immunology practice. And one of the things that I notice all the time, which I think, unfortunately, some of my pulmonary colleagues don't pay attention to as much, only because I've also done a lot of like functional medicine training and holistic training with
Hmm.
mindfulness meditation. And yoga. It kind of opened my view. And what I
Yes.
typically see with asthmatic patients or anyone with chronic respiratory, they have shallow breathing.
Hmm.
And that is exactly what you're saying is that's a big risk factor for not clearing your secretions and being more prone if you get an infection, whether it's from a virus
Yep.
or it ends up eventually becoming a bacteria, that you get a pneumonia because it's anatomy. You can think of it like you said as plumbing or highways. When the highways are blocked, bad things happen.
Yeah.
And using something like this is basically like doing a little gym action, only you can do it right at your desk. As is like, diaphragmatic breathing, basically like
Hmm.
Lamaze kind of breathing. I think all very important. And essentially, even I once was watching, or I think it was in his books, Dr. Sanjay Gupta of Fame on
Hmm.
CNN. He mentioned in one of his book, I forgot the name of it, but he talked about how he felt like you decrease pneumonia by widening your chest expansion by doing like just like simple
Hmm.
stretching or weights, and again, you tend to think of an infection, oh, this bad infection, it's going to get
Hmm.
me and do me in. What does you in is that, again, you're like you said, you're not using your full anatomy to take in good breaths and to expel the breaths and to let the secretions come out. Because people always forget too, it's kind of like ironic and funny. Like people are like, oh, I'm spitting up mucus, and mucus is so bad for me. Not realizing that's what's trapping the bacteria or viruses, but you just got to get it out. Otherwise, you keep on coughing.
Dean, this is again, this is where Madison Avenue marketing, is doing us a disservice because
Right.
you're absolutely right. The front line. So our immune system has all the levels, and you're the expert on this. But so the medieval catapults are making mucus and trapping viruses and bacteria in the mucus, and then coughing them out, and they're gone. And so if you want to make sure that you go from nothing to pneumonia, let's suppress coughing. Okay. So I get it
Right.
that it's no fun to cough, and if you have a partner, you got to sleep in another room and all of those sorts of things. But what you should do is accelerate through the coughing process as much as you can to get your immune system to give you what all it's doing is giving you the 3 to 4 days for the antibodies and T cells to kick in. They're just buying time.
Exactly.
And you should play with what your body's doing, not fight it with something off the shelf that stops you from coughing.
And one other thing too, I think you mentioned in the book, but again, somebody else told me about this too, and I used it when I got COVID about 2 years ago, and I and made it fortunately a very minimal course, and I just used it a few weeks ago when I got some type of respiratory infection. Is I love I pulled out and I got it online those facial steamers.
Yeah, exactly.
And I actually put a little teaspoon of baking soda because that's what somebody else told me to. And I was inhaling it. And I can't tell you, I want the listeners to think about this. I tell all my patients, but again, like Dr. Quay mentioned, I can only see maybe 10 or 15 patients a day. I'm not getting to thousands as we can on this podcast. I was inhaling that steam like 2 or 3 times a day. My respiratory symptoms compared to some of the other colleagues and family members that had it, I got better in 2 or 3 days. And I not
Of
only that,
course.
I felt really good too. It was better than any medicine you could take.
You were hydrating the thick mucus. I mean, one of the
Yeah.
challenges, the mucus gets a little too thick, and you're
Yeah.
and the wa and they but it takes up water like crazy. It's
Yeah.
hygroscopic, so
Yeah.
it thins it out, and then
Well,
that's where the bacteria get trapped, or the
yeah, I mean, I guess like
viruses or
what we used to
whatever.
use with the infants with croup. There was
Yep.
something to that.
Yep. And
Um,
I'm sorry, I need to touch on a point you just made because I
sure.
I mean, again, it's this Venn diagram there. So the the toxic component of B venin is melatonin. It has a very furin cleavage
Oh, I
site
know about
section
that.
in
Yeah.
it, and the one of the key things you can do to make the sting go away is take the pH up above 10 with either bicarbonate or ammonia or
Oh,
something like that. And that's
interesting.
exactly what you're doing when you're putting a little
Oh,
bicarbonate in there. You
wow.
you're 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 causing it to destabilize at high pH.
Yes, I think you mentioned that in the book, which I couldn't find it. I read it like the first time, and I don't know. I've been searching the book to find it again. Okay, let's go on to one more thing, which
Sure.
again you mentioned at the time of your first book, "Stay Safe," and then there's obviously we're going to get into some other things in your second book, "The Origin of the Virus." But you said in the book at the time, and again, it was crazy, and we thought it would take several years. You wrote, "Don't bank on a vaccine," but yet the vaccines came pretty fast. So I'm just curious, again, in your purview. Um, do you feel the vaccines? I know I'm going to inject my opinion after that. Do you feel the vaccines did what they had to do? I mean, what's your overall opinion on the COVID vaccinations?
Well, yeah, and this is such a fraught topic, but
I know, I know. I'm
nonetheless,
not. I'm not going to get political on this. Promise.
and I'm not
I really
either.
want
I
to
won't
stick.
let you.
I want to stick to the science, and I'm going to give you my thoughts. But again, you're such a super thinker. I want to hear your thoughts because again, you were looking at the time. We were in the midst of the pandemic. There was no, treatment or even prevention at that time.
Mhm.
Now there has been.
But
What
what did I
and
do? What did I
yeah,
do, Dean? So at that point in time, I said, okay, this is a coronavirus. So let me see. And there are other coronaviruses in the world. There's a cat coronavirus
yeah,
that
that's
actually
right,
kills cats, et cetera, et cetera.
right.
So there's like half a dozen, maybe 10 of them that are really important that in the past I've said, well, let's look up how good we've done at making vaccines for them. And we are 0 for 10. That was
That's
that
not
was my
good.
that was my foundation of saying,
Right.
okay,
Yeah, okay.
we're 0 for 10 with previous coronaviruses. This is a coronavirus, so this is challenging, and there's some very specific reasons why it's challenging. And so, and then let's talk about the outcome, which is I think we all are definitely everyone has had what I'll call the original definition of a vaccine, which is you take it and then you don't get infected and then you don't get sick and you don't spread it to anybody else. It kind of doesn't do most of those
No,
things.
that's true. But okay.
Yeah,
Well,
I mean,
okay. So,
in,
so let me ask you a question, if I can't ask person. Did you get the vaccine yourself?
So I can't remember when they came out, but and we live in Taiwan from August to May while my daughter goes to
Okay.
school here. My
Right.
wife is Taiwanese, and then we live in Seattle from May to August.
Okay.
And yeah, I mean, I'm a business guy. I have to get on an airplane, every
So you
month
got him.
going around the world. So I got
Right.
the two Pfizer vaccines.
Okay. I'm
And
gonna
then to use my gym in Taiwan, I had to get a
okay.
third one. And that was the old-fashioned traditional one. It was developed by Taiwan itself. It's an old-fashioned, just it's a protein with adjuvants, like 20 years ago.
Yeah.
It, you know,
I'm
so
gonna
it was possible to make that.
Yeah, I'm going to just check my thoughts about this,
Sure.
for whatever it's worth. And again, as I said to people, please, it's not political, but I do, as a doctor, I felt strongly about this. I mean, we saw, unfortunately, on the front line, I mean, I know colleagues of mine who've died from COVID, doctors and nurses, and it was frightening. Again, this is a virus we believe we never saw before. Our bodies, our immune system never saw before.
Mhm.
So it was like a nuclear explosion, you know. And while again the vaccine came out pretty quickly, although the technology had been around for a while. I mean, I guess like science in general, when you go back to Louis Pasteur and some of these other people who started vaccinations, they worked with a lot less science than these RNA
Yeah.
viruses.
Yeah.
So we had to do something. We had to do something to try to slow. I
Mhm.
put the method like slow the train down because this thing was just wiping through our society. Um, did it do that? Again, some of the studies seem to show that it decreased deaths, maybe
Mhm.
decreased morbidity. So I was a favorite. I got vaccinated. I
Mhm.
didn't personally get the boosters. I've had Paul Offit on the podcast. I don't know if you're familiar with him. He's a great
Mhm.
vaccine expert at University of
Yeah.
Pennsylvania, and he wrote a book also on this. Like when's this going to be over? But I liked what he said on my podcast because I felt this was kind of true. So I had gotten the initial vaccines. Then
Mhm.
about a year later, I got the virus from my son who's come visiting me when we were in Florida for vacation. He had just been at a big Michigan party because they were in like the playoffs and football.
I'm a Michigan
Yeah, a big
grad.
guy. I know they had a good year
If
last
he's
year.
teasing me about that, I'll let
Uh-huh.
that pass.
But but I felt that, and what Dr. Offit confirmed, that he says, like, if you've been vaccinated and you've had the virus, overall, you don't really need the boosters. They're not really doing a whole lot. And of course, there's risks. I mean, these are very potent. vaccines, for
Hmm.
maybe, and you could explain this, maybe because of that furin cleavage site thing or the spike proteins. I'm not sure why, but I mean, unfortunately, I've seen or heard stories of people getting strokes, Guillain-Barré. I mean, the range seems to be a lot higher than with any other vaccine. And of course, that could happen with any vaccine, but again, the rates seem to be higher. So that's my little diatribe on this. What's your thoughts? And this will maybe start to get a little controversial or political. We'll try to keep it within science. Is you mentioned in your second book, The Origin of the Virus, which I really liked a lot too. But again, you talk about this whole idea of gain of function research,
Hmm.
and you kind of are a proponent of the lab leak. I'd like you to explain this a little bit to the listeners the best you can. And also, I mean, does it matter how the virus got
Hmm.
out there?
Yeah, well, let me get that.
Go ahead.
Can I go
Sure.
back and just kind of
Yeah, of
go through
course.
a little bit of my thinking about the
Yeah,
immunology?
absolutely.
So again, when you have a virus, um, your immune system can really only attack it when it's outside the cell, in the bloodstream or in the fluids or that sort of thing. And you have antibodies and you have T cells. Once it gets into a cell, it spends about 12 hours making, on the order of, it's a very small number, shocking, like 10 to 100 copies of itself. It makes millions of subgenomic copies of its RNA. It's hugely inefficient, but nonetheless, okay. So we only can attack it with the immune system when it's outside the body, and it's only its structural proteins. So it makes about 10 proteins, but only 4 of them end up in the virus. The other 6 are left inside because they're the factory of making more viruses. And so it's the spike and the N and the M, and the envelope. So those are the 4 proteins. When you look at people who have been infected with COVID before there were vaccines and said, what are they making antibodies against? The thing they're making antibodies the most to is actually not one of the 4 structural proteins. This
Oh
was really a
wow.
shock,
Oh
and this gets into
wow.
my gain of function
Wow.
stuff.
Yeah.
But it's a protein called ORF8, which modifies the immune system. It doesn't stay in the cell. It doesn't end up in the finished virus. It goes into your bloodstream and tamps down the immune. It goes specifically to the immune system and
Oh
tamps it
wow.
down. It has
Wow.
evidence of being having engineered into the virus. But my point is that I think that we've made it at a simple level, but I want to go a little bit higher. The vaccines hit the spike protein, and the viral infection hits every protein. That's important.
Mm-hmm.
So it's the
Mm-hmm.
ORF8, and then it's the nuclear protein. And so the order of antibody production is ORF8 the most, spike next, nuclear protein third. And so, and then I misspoke. ORF8 the most, spike next, nuclear protein third. So I actually, very, very early on when this came out, said we should be adding the ORF8 gene to the
The
vaccine
vaccine. Mm-hmm.
because it's so potent in what it does.
Mm.
Well, but guess what? Guess what? We did it ourselves. The the ORF8 causes the virus to grow slightly slower than viruses without it. And so almost every virus in circulation now has a deletion in ORF8 and it no longer is functional. So we beat it immunologically,
Oh
and
wow.
through evolution because we hit it hard with our antibodies and the virus said, oh, this isn't working for me. And so it's just that I'll stop making that. So that's my perspective on that. But so Dean, I've spent literally 3 years, and how I ended up working inside the State Department, at the end of the Trump's administration, and have now testified in Congress 3 times and helped with some legislation there. So there is there is no evidence this did not come from a laboratory. All the evidence is that it did come from a laboratory. All the evidence is that it is an accidental leak. And the reason it's important, Dean, is this 1% highly infectious virus caused 20 million deaths, plus or minus five,
Mm-hmm.
maybe,
Mm-hmm.
and $22 trillion in damage. This and with my forensic with so friends around, I've developed a pool of people around the world. Like you said, everybody pitched in together, and so we have a forensic team that can sort of do CSI type things inside the Wuhan Institute of Virology from a computer anywhere in the world, and they are working. Remember, SARS-CoV-2 is 1% lethal or less, and then they're working on a 30, 47, and 90% lethal virus doing gain of function research. So these are it was an accident. SARS-CoV-2 was an accident. It's always an accident. There's 7,000. We know that there were 7,000 lab accidents in the US over the last decade because it
Mm,
happens. Remember the
yeah.
movie Jurassic Park? The guy says
Right.
biology finds a way.
Yeah,
So,
sure.
so I've also done an analysis called a tipping point analysis where you look at energy supply from the ground to the gas pump, a food supply from the field to the grocery store, health and fire protection, and hospital staff. Four key ingredients. If you break those in a society with more than a 10% lethal virus, it'll be a 200-year setback like the 1346 Black Plague.
Wow.
So why does it matter? It matters because this could all of this work could end civilization, in a
Oh, so
crazy way.
it's like a nuclear,
Well,
bomb.
the nuclear bombs in Japan covered 10 square miles and killed 400,000 people. COVID, SARS-CoV-2 went to every corner of the world, including the Antarctic uh, research stations. 6 billion people infected, 25 million dead, et cetera, et cetera. So,
Yeah, but yeah, it's
um,
magnified, right?
yeah,
So
that's why.
are you saying though that also so like the point of gain of function, is it to learn to prevent something? Is it used like as for a military advantage? What I was never really sure why
Yeah,
um
there's lots of probably true but highly inflammatory topics to talk about this.
okay. Okay.
Let's talk about what the academicians at Harvard and every
Okay.
university in the US will say,
Okay.
including Dr. Fauci, um, who, I mean, he was my hero in the 80s with what he did with AIDS and HIV and
Right.
all of those sorts
Right.
of things.
Right.
And he is a Bible carrying believer in gain of function research. For this work that I've done, I reviewed all 250 papers on gain of function to see what would be the possible use in medicine for these.
Mm-hmm.
I found only one trivial one, which was that we knew that if we changed the spike protein, we could go from one host to the other. That's kind of interesting, maybe useful, but we now know we just proved it. We knew the structure on a Friday in January, and by Tuesday we were making the messenger RNA sequence to make the vaccine for that protein. That proves we need no foreknowledge of the next virus to make a vaccine. Hopefully, it will be better. There's some issues with the
Mm-hmm.
current vaccine that I can
Mm-hmm.
talk about that we didn't know about and we learned along the way. But their purpose is to say, well, let's make a vaccine or we can make drugs against a future pandemic. But the challenge is these tools are so powerful. They can do 1,000 years of natural evolution in a cave in an afternoon.
Wow.
So once you do 1,000 years of that, and then there's also what I call gain of opportunity. So these natural viruses are in caves, mostly in the equatorial parts of the world, equatorial, uh, 30, 25 degrees and below. And they see a human twice a year. And they're inside a bat, so their circle of influence is 20 kilometers. You bring them back to a lab in Wuhan with 11 million people. The subway line for the lab carries 1 million people a day. And by the
Mm.
way, it ends at the airport. So the state power called me up when I wrote a paper saying line two of the Wuhan subway is the COVID conduit because someone in the lab walked down, took the subway. 1 million people are in the subway. They're coughing and
Mm.
sneezing, etc.
Mm. Mm.
They go to the airport, and you are in 12 cities within 12 hours nonstop.
Yeah, this is not
And when I looked at the
containable.
mutations in those cities, they were clearly nonstop flights. So that's why I really am pretty passionate about this. We need to tell, and I helped Rand Paul write a piece of legislation on allowing this gain of function research. A lot of people just say ban the stuff. I'm too much of a
Is that
scientist to.
is that possible even, because
Oh yeah, absolutely.
there's always going to be bad players or whatever that are going to,
Well,
use this to their advantage. So,
there are first of all, the bill, I restricted the bill to the 68 things in the world, toxins, bacteria, fungi, and viruses that kill people easily in high numbers. They're
hmm
called select agents. You need a license to work with them in your lab already. The FBI comes out and interviews you and looks at your lab, and actually like 1% of the people get rejected because the FBI says there's something here in their background that we don't like. So
hmm
so they're already established. So I'm saying it's only these these agents that we're doing gain of function on that needs to be highly, highly restricted. And it's 1% of the NIH budget and 1% of the grant. So if it disappeared, no one would notice except the 50 or 60 scientists doing this. They'd have to find something else to do with their lives.
Really? That's really fascinating. Well, I don't know. We've covered so much information here today. I mean, it's fascinating to talk to you. This was a big treat for me. Is there anything, Dr. Quay, you'd like your our listeners to go to highlight like, the work you're doing? I know you have a newsletter, just so they can keep up with your thinking, which I find very interesting.
Yeah, so the website is www.drquay.com. So, yeah, I write emails to folks like once a week on healthcare. I am not your physician. I'm not giving you medical advice. I'm giving you, good advice about your health.
Information,
Information, yeah, free of charge. I
yes,
don't
which is
charge
really
anything. And all
wonderful.
the money from that COVID book wasn't a lot, but it went to a charity
No, very
of,
nice.
of of soldiers who were
Hmm,
injured but giving back into their own communities, and they need
right.
wheelchairs and stuff like that. So
Yeah.
anyway, so yeah, www.drquay.com. I do a lot more on Twitter where I give snippets of things that end up being looked at a
I'm
lot.
gonna follow you now. I didn't I didn't know you were on
Okay.
Twitter or X. Okay.
Yeah, yeah. Hey, Dean, so one of the things that has come up in some of my, not millions of views, but tens of thousands or 100,000 views, is this concept of, and this is your field, so you can really weigh in better than I can, but it started with a very nice study out of Germany. It's now been replicated 3 or 4 places, but what you see in patients with 3, 4, 5, and it goes up with time, vaccinations, is you start to see an antibody class switch to IgG4 antibodies against
Hmm.
spike protein, which are the class of antibodies for tolerance. That's what
That's
you
right.
want to
That's
make with
right.
allergens. So,
Right.
Dean, I mean,
You know so
you're the
much.
guy to say, hey, look, this is starting to look like the allergy treatment I use with my patients, where I give them small amounts of it over and over again to switch from the nasty IgEs to
Right.
the IgG4s that
Correct.
are tolerant. And so, some of this findings that people who have had the vaccine get infected more easily could literally be because they're making IgG4. So,
Unfortunately too, as you may know also, like again, this is like a little, an adjacent field, like in rheumatology, unfortunately, when people have high IgG4s, not from allergies, it causes, rheumatological and a lot of other systemic organ problems. So
yes,
interesting.
yeah.
Wow. Well, what a discussion. I mean, this was, as I said, very exciting and enlightening for me. I hope the listeners appreciate. We went the range from breast cancer to COVID. So there's a few times you're going to be on a podcast and get that discussion. So again, Dr. Quay, thank you for your time and staying up late tonight in Taiwan. Good luck. Please keep on bringing out your brilliant ideas and continue your great work at Atosa.
Thanks, Dean. It's really great to speak.